students, welcome to the next session from units and dimension. Last class we have learnt about various dimension analysis, and today we are continuing the second part of dimension analysis. Last class we have seen the dimension analysis of various units. Hope you remember at least a few of this one. Else pause the video and just revise it what you have learned from the first sessions, and here we'll continue the next one. Okay, so the next topic, still we are under dimension analysis only, but we will move to the next second topic under dimension analysis, which is called homogeneity. So write on the heading, principle of homogeneity. Principle of homogeneity. Principle of homogeneity. This is a heading. Okay, homo means what? Okay, mostly in your 10th standards and all you have learned about two words, right? Homogeneous and heterogeneous. Hetero means mixture, homo means same, okay, equal. So homogeneity in the sense, there are the definition of homogeneity in the sense, the first point is, in a physical equation, in a physical equation. So in a physical equation, left hand side equal to right hand side. Left hand side of the equation is equal to right hand side of this equation in dimension wise. Let me take an example. Last class we have learned about the dimension analysis. F is equal to ma. F is called force and mass into acceleration. You have learned on 10th, 9th and 8th standards, right? Newton's second law. What is the dimension formula of F? First we will find the dimension formula of F, then we will find the dimension formula of ma. So first we will find the dimension formula of F. F means what? What is the dimension formula of F? I know, mlt raised to minus 2. This last class we have written, right? Now we will see how to find the dimension formula of ma. Dimension formula of ma. So mass in the dimension formula m, acceleration unit is what? Meter per second square is a unit. So meter is L by second square. Second square means time square. If you further simplifying this, we will get mlt raised to minus 2. Now if you see this one, left side of the equation is equal to right hand side of this equation. That is the word meaning which is called homogeneity. Principle of homogeneity. Left side of the equation is equal to right side of the equation. That is called principle of homogeneity. Okay, dimension analysis wise both sides are same. Okay, this is one concept. Here you can see in this equation left hand side and the right hand side there is only one term. Sometimes the situations will be little different in the sense, for example, another, this is some kind of one example. Example number 1, F is equal to ma case. Next, second example. The example in the sense different models I am showing to you. So different example. For example, if the equation is coming like this one, V is equal to U plus AT. This also you have learned, right? Motion equations. So in this case, what will happen means dimension of the left hand is equal to dimension of the U is equal to dimension of the AT. Okay, a very critical point of the dimension analysis means same dimensional quantity, same dimensional quantity can add or subtract. Same dimensional quantity. So which means that this will have same dimension. That's what we can add U with the AT, because U, the dimension formula of U is equal to dimension formula of AT. This is another definition of homogeneity. Homogeneity says that LHS of an equation equal to RHS. Point number 1. Second point, the same dimension formula quantities can be add and can be subtract. Now you know V is called final velocity. What is the dimension formula of V? What is the dimension formula of U? U and V are called dimensions, dimensional quantity. V is called the final velocity. Okay, final velocity. This you will learn it in one dimensional motion chapter also. Don't worry. We have already done in school also. The dimension of final velocity, or simply it is called velocity, the unit is meter per second. So what is the dimension formula? Meter per second. Meter means length, length is called meter per second, second means time, so L by T, which is equal to LT power minus 1. Now if you are calculating the dimension formula of U, how it will come? U is also equal to, it's called initial velocity, final velocity and initial velocity. If a car is started to move, then when it is moving after 10 seconds, if I am looking to the car, so the car is started to move means starting velocity is called initial velocity. This is called initial velocity. This U is called initial velocity. So car is started to move. Car is moving, and after 10 seconds, if I am looking what is the speed of the car, so that time I can say the final velocity of the car in a simple words. So that is done. Next one is here we have something called AT, acceleration into time. AT, I am writing it clearly, acceleration into time. What is the dimension formula of AT? Acceleration means, what is the unit? Meter per second square. T means time, again multiplied with the second, second and the second cancel. So what is the unit of this one? Meter per second. Meter per second in a dimension formula, L divided by second, second means time, which means what? LT power minus 1. So now if you are looking to this one, we have three parts will be there. We have V will be there, we have U will be there, and we have AT will be there. Dimension formula of V is this one, dimension formula of U is this one, dimension formula of AT is this one. All are equal. That equality is called as principle of homogeneity. Principle of homogeneity. Principle of homogeneity, two concepts, LHS equal to RHS, point number 1. Second one, same physical quantities you can add and you can subtract if it is same. This is second example, the second model of question actually for the NEET and JEE examinations. We will see the third one. Third one is also comes under the principle of homogeneity concept, but it is slightly the different approach. Okay, slightly the different approach in the sense the way of solving the problem is different, but the way in which we are understand the concept from the homogeneity will be the same. There is no difference with respect to the homogeneity stuff, but the way in which we are representing. So we will move to the third example. So example number 3. 3 means the third model, that's all. So what is this represent? What is example number 3 is representing? One model of questions will come. For example, if they are saying, let me take an example. Mass has dependency on, mass has dependency, you know the dimension formula of mass, right? Mass has a dependency on force, velocity and time. Mass has a dependency on force and velocity of the time. Then what is the dimensional formula? Then what is the dimensional formula of mass in terms of F, V and T? One example, one question actually is an example, so this will give you representation. Listen to the question. Mass has a dependency with respect to your FVT. Then what is the dimension formula of mass? You know the dimension formula of mass. What is the dimension formula of mass? M, simply M, mass. Okay, but the question is asking what is the dimension formula of mass in terms of FVT. They will tell you some options, F raised to 1, V raised to 2, T raised to 3, something like that. You will get different options. So how to solve this kind of motion? The first point is, if some quantity depends upon some other quantity, depends upon means immediately you can write M is directly proportional to FVT. This is the first step in this model of question. Depends upon means directly proportional. Sometimes it may get changed. Sometimes it may get changed means this may comes as inverse proportions and all. But for all this kind of model kind of questions, the fundamental principle is M is proportional to FVT, because mass depends upon FVT. If they are telling something, for example, kinetic energy, energy depends upon X, Y, Z, then you have to write E, energy E is proportional to X, Y, Z. So same way, whatever is given in the question depends upon that we will write. Now what we have to do? This is a kind of equation, right? We told it is proportional to. How a proportionality sign will be replaced in physics? Proportionality sign is replaced with a constant. I am writing a constant k. So proportionality become equal to FVT. To replace proportionality with equal to sign, we need a constant. Here I put a constant called k. Okay. Now I have to find the dimension formula of all these things. So here I know dimension formula of small letter m is equal to dimension formula of KFVT. K is a constant, I told. So we can omit k. K is a constant means k is a number. Either it's 1 pi, 2 pi, or just a number 1, 2, 3, 4, 5, 6, 7, etc. So it's maybe any number also. So I am not bothering about k because k is dimensionless quantity. We can omit this one. So I am saying this dimension formula of m is same as dimension formula of FVT. We have to derive the equations for this one. This is what's our aim. What's the dimension formula of m? You know it is capital letter M. Okay. What is the dimension formula for force? Force in a dimension formula is what? We will write will be here. The dimension formula of force means what? Force in equation mass into acceleration. So m in the dimension formula m, acceleration LT raised to minus 2. I already told, right, last session also, LT raised to minus 2. Next one is called V, is called velocity. What is the dimension formula of velocity? LT raised to minus 1, because the unit of V is meter per second. The unit of A is meter per second square. That's what LT power minus 2. Here LT power second will go to numerator, LT power minus 1. Last one is the dimension formula of time. Time means T itself. Now we have to put all these people here. Okay, F in a substitute M L T raised to minus 2. First one. F V in the formula LT. Okay. Okay. This is whole together X. Whole together X. Why I am saying like X means here itself you can write mass is proportional to. Mass is proportional to one quantity. Okay, left side. Here you can put it is proportional to FVT. But you don't know what is the power of F. You don't know what is the power of V. You don't know what is the power of T. It just depends. So I am putting different variable will be here because I don't know the power. Not to know the power I am putting will be here. So X, Y and Z. Same will continue here. Because as I told before, if X will be equal to minus 1, then it is an inverse proportion. If X is equal to 1, then direct proportion. X is equal to square, then it is a quadratic form. Quadratic equations, 10th standard, right? Quadratic equations. F power square. So this is written, and the formula of V already we calculated. LT power minus 1 whole raised to Y. Then the other one T power Z. This is not T square, T power Z. We'll continue here. Here M. Okay, how many M's will be here on the left hand side? Only one M, because it is mass. Mass will have dimension formula M. So the dimension here, the power of M is 1, LHS 1. So I am just taking M terms together. LHS, what is the power of M? 1. So 1 equal to on RHS. Here M, here no M, here also no M. So here M, what is the power of here? M 1. 1 into X. So it is called 1X. Equation number 1. Okay. Next we will take L terms together. L is the next term. MLT. Dimension formulas are MLT. So ML, L. What is the dimension formula of L on the left hand side? Left hand side equal to right hand side. That is called homogeneity principle, right? So left hand side there is no L. So left hand side it is 0, no L. What is the right hand side? Here L will be here. Here L will be here. Here there is no L. So L is 1. So 1x. 1 into x. Here 1 into y. So x and y together. How we can say 0 equal to x plus y. 2 terms. Okay. So actually here how it will come? L power x multiplied with L power y. In mathematics, L power x into L power y is equal to L power x plus y, maths. Okay, L power x plus y, that's what, here there is no L, so here the power of L is actually what? 0. The power of L is 0 will be here. If some x raised to 0, L raised to 0, what is the value of power 0? 1. Power 0 is 1. So here 1 means nothing, just 1 into m means m. So L power 0 is actually here, that's what 0 will be here. Corresponding right side is what? X plus y. So 0 equal to x plus y. Next term is what? M L T. T. We have to take a t. Any t will be there on the left side? No. So what is the value? 0. Any t will be there in the right side? Yes, t will be there. What are the t? Minus 2x, minus 1y and z. 3 terms, 3 places t will be here. Here minus 2 into x. So equal to minus 2x plus. Here what is coming? Minus 1 into y. So minus 1y plus. What is coming will be here? T. T power z. So time in a dimension formula 1. So 1 into z, nothing but z. So we have 3 equations are available. We have to solve these equations. We have to solve these equations. If you are, once you solve these equations, now I'll tell you, this is not complicated, it's very simple. Only what we have to do, we need to find out x, we need to find out y, we need to find out z. If you get this x comma y comma z, you can put it will be here. So your formula will be mk. Here we have x, here we have y, here we have z. This x and y and z we have to find it out. That is our aim. Okay, that is our aim. So we will solve it further. You can also solve, you can also post the video. Just mathematics, we have 3 equations will be there. I have to solve all these 3 equations. Then I have to get the value of x comma y comma z. So I will keep these equations will be here. Rest of the things I rubbed out. Okay, so we have to solve this one. Here say 1 equal to 1x. So what is the value of x? So we clear x will be equal to 1. So this is over. If I am substituting x is equal to 1 in these equations, so how it should come? Equation number 2 become 0 equal to x in 1 substitute here. First equations I am substituting minus x is equal to 1. X is equal to 1 plus y. So what you will get from this one? Y is equal to minus 1. So it is over. Now third equation, sir. Third equation is 0 equal to minus 2 into x. X in the value already I know, minus 2 into 1 plus minus 1y, minus 1 into, what is the value of y? Y is also minus 1 plus z. So 0 equal to minus 2 plus 2 plus z. So z is equal to how much? 0. Z is equal to 0. So if is minus 2 plus 2, so minus 2 into minus 1, okay, here one mistake, right? Minus 1 into 1 means 1, minus 1 into minus 1 into minus 1 means plus 1. So what is the value will be coming? Minus 2 plus 1 minus 1 plus z. Left hand side 0. So z equal to 1. So all the 3 value we got. X is equal to 1, y is equal to minus 1, z is equal to 1. We are substituting this. We are finding a formula for m. K you can omit, k you can add also, k you can omit also. No issues because it's a constant. So m is equal to f power x. So f power x, x means what? So f and v power y, y means minus 1 and t power z. So t power z, z means 1. So this is the formula of mass in terms of FVT. This type of question, it will take little bit of time. Only if you are practicing this kind of model only you are able to get it. Okay. So mass is equal to FVT. So mass is directly proportional to V. F mass is directly proportional to V raised to minus 1 or inversely proportional to V, and mass is proportional to T. So F V power minus 1 and T is the dimension formula of mass in terms of force, velocity and time. This is a concept. Okay. Now I will give you a small exercise also. You try it out and you will get the answers. It's quite simple. Now I will say the second model of the question, the second example. I'll do one more examples. You can also try the pause the video and you can try. Write out the question. Write out the question. The energy depends on. Write down. Energy depends on. Energy depends on. Energy depends. Energy depends on. Not energy, sorry, surface tension depends on energy in bracket E, velocity in bracket V, and time in bracket capital T. Then what is the dimensional formula? What is the dimension formula of, this is my example number 4, I guess. Okay, then what is the dimension formula of surface tension? In short, I have written surface tension in terms of, tell me, EVT. In terms of EVT is called energy, V is called velocity, T is called time, that's all. And left hand side surface tensions we will write. So which means surface tension is directly proportional to energy, V and time. Constant you can write, or you don't want to write it at all, anything. You can assume constant is equal to 1. So K is equal to 1. So surface tension is equal to energy raised to X, V raised to Y, the same way what we have done, T power Z. Okay, what is the dimension formula of surface tension? You remember, you know dimension for surface tension, the formula is surface tension is equal to, we'll first find formula of everyone. Surface tension is equal to force per length. Force is equal to what? Mass into area divided by length. Okay, mass into area divided by length. So mass dm, acceleration LT raised to minus 2 divided by L cancel, mt raised to minus 2 is the dimension formula of surface tension. Dimension formula of energy, any type of energy. So dimension formula of energy is equal to, what are the type of energies we know? I know potential energy mgh, potential energy mgh. You can take this one, you can take kinetic energy half mv square, or energy is equal to force into displacement. You can take energy, any energy equation, half mv square you can take, or you can take a force into displacement. Force into displacement is simple because already we know force in very short way, right? Any equation you can use. All these are the different equations of energy. F into S, I am taking F into S. So F in a dimension formula ml t raised to minus 2, S in a dimension formula L. So energy to dimension formula ml square t power minus 2. So energy to dimension formula we got it. Next one, velocity V. What is the dimension formula of velocity V? Lt power minus 1. So we got it. Next one is time. What is the dimension formula of time? Time is called T. We have to substitute, everything will be here and we have to solve. Now we are going to substitute LHS mt raised to minus 2. So LHS mt raised to minus 2 is equal to RHS e power x, e in the dimension formula we got it will be here, ml square t power minus 2 whole power x, and v power y. V means Lt raised to minus 1 raised to y. This multiplied with this, all are into each other. So t power z. So t power z. We have to equate all the m terms from left hand side with right hand sides, and we have to equate all L terms, then all T terms. So we will go one by one to equate these steps. Okay. So let's continue. What is the power of m? First we will equate m terms. What is the power of m on LHS? M raised to 1 here be here. Here it is 1x. That's all. So 1 equal to 1x. Equation number 1. We have to equate L terms. Any L terms on the left hand side? So there is no L. So L equal to 0. right hand side here 2x, so 2x, here 1y, 2x plus 1y, equation number 2. T terms, what is the t of power will be here, the power of t is minus 2, equal to, what is the power will be here, minus 2 into x, so minus 2x plus minus 1 into y, so minus 1y plus t, this is z, this is not t square, t power z we have written here, right? So t power z, so plus z, so we have 3 equations. Next, I am asking you, what is the next step? What is the next step? We have to solve all this, right? Then what we will find? We will find x, we will find y, and we will find z. Then we will substitute here, and then we will say, hey, surface tension has the formula e power x, v power y, t power z. So we will solve these parts. The next one, x, y, z stuffs we have to solve. Okay, so I am removing the questions. If you have not written, pause the video and note down the notes perfectly. Okay, so these things I am removing. I need only this. Here we have to substitute x comma y comma z. Okay, so x will be equal to 1. I already got. X is equal to 1. I already got. If I am substituting x is equal to 1 will be here in the second equations, what should I will get? 0 equal to 2 into 1 plus 1y. So y will be equal to what will get? Minus 2. And third steps, minus 2 equal to minus 2x, x is 1. So minus 2 into 1 plus minus 1 into y in the value, y is also minus 2 plus z. Okay, 1 minus 2 left hand side and right hand side got cancels. So this minus 2 gone. Here minus 1 into 2, minus 1 into minus 2 become 2. So 0 equal to 2 plus z and z equal to minus 2. So we got all the 3 values, right? X we got, y we got, will sum. Now the surface tension is equal to a constant. Constant I am assuming 1. So equal to sign e power x. So e power x in the value 1, v the value means y, v power y. So minus 2, t power z. So t power minus 2. This is the dimension formula of surface tension in terms of energy, velocity and time. So 2 examples I have done, right? Totally 4 examples I have done. Last 2 examples are a little bit of time consuming, but if you are practicing you can able to attend. This is the sessions from principle of homogeneity. You can equate any terms. One more additional note I have to say. Write down one note, one additional point, additional point. Power of any quantity, is dimensionless. Power of any quantity is dimensionless. Okay. If you have some power, for example, x square. Okay, x square, that is 2, x square, x in the square. X in the square means power equal to 2. So 2 will have any dimension? No, because it's a constant quantity. So the power of any quantity is a dimensionless quantity. So remember the concept from principle of homogeneity. And if you still have some doubts, watch this video a couple of times. So principle of homogeneity, 2 things. Any physical quantity which has the same kind of natures, like same dimension, we can add and subtract. And LHS of an equation will be equal to RHS of an equations. And the third category of question is something like this one. If you have telling if some quantity surface tension is depends upon energy and V and T, then you can create some formula for surface tension. The previous question is also will be the same. Mass will have a dependency with the force, velocity and time. So mass is directly proportional to FVT, x, y, z. We have to find out the value of x, y, z. So whatever you are getting, E v power minus 2, t power minus 2, this is the correct answer. You have different options will be there, E v power minus 1, t power minus 1, E v power plus 2, t power plus 2. Lot of confusing options are there, but if you know how to solve these questions, then it's easy. Okay, this is second part from dimensional analysis and the principle of homogeneity. Okay, thank you.